Saxon's Trig, Lesson 24, Sums of Trigonometric Functions and then Combining Functions, page 172. Part A is, as it says, sum of trigonometric functions, a combination of what you already know about using your reference triangles and finding like the cosine of 60, finding the answer to sine of 45, and then combining those together in a sum. Therefore, you're adding them. So that's all they're doing. So in the first example, they give you cosine of 60 degrees plus sine of 45 degrees. They just want you to take what you knew from before, the reference triangles 30, 60 with the 90. Hypotenuse is always 2. Opposite the 30 is 1. Opposite the 60, root 3. Cosine is ca. So we want adjacent over hypotenuse. The adjacent to 60 is 1. The hypotenuse is 2. So this is 1/2 plus. And then we need the other reference triangle, 45, 45, 90. Both legs are 1s, hypotenuse root 2. Sine is so we want opposite of, doesn't matter which one we choose, it's 1, hypotenuse is root 2. So this is 1 over root 2. We need to add these together. We're back to some algebra stuff, except that I want to fix this by multiplying it by the root 2 over root 2 so I can get rid of that radical in the denominator. 1/2 plus root 2 over 2. Well, now just fixing that gave me the same common denominator, so it's 1 plus root 2 all over 2 for its answer. Example 2, same thing. Tangent of 30 degrees plus cosine of 45 degrees. So I'm going to refer back to the triangles that we just drew for reference on the last one. Tangent of 30 wants TOA. So the opposite of 30 is 1. The adjacent is root 3. So we're going to have 1 over root 3 plus cosine of 45, ca, though that's here. So adjacent is 1, hypotenuse is root 2. And again, I'm going to fix both of these denominators, multiply by root 3 over root 3. So we have root 3 over 3 plus, multiply this one by root 2 over root 2, root 2 over 2. Now what is the common denominator between them? 6. So this one multiplied by a 2, put that in the numerator to keep us balanced. This one multiplied by a 3, put that in the numerator to keep it balanced. 2 root 3 plus 3 root 2. These are not like terms because the roots do not share, they're not the same number, over the 6. And even though these reduce, they don't all reduce by the same number, so it is stuck at that large fraction. Example 3, tangent of 45 degrees plus 2 tangent of 30 degrees. So my tangent, TOA, on a 45, opposite over adjacent, we know that that's 1 over 1, so it's 1 plus 2. And then the tangent of 30, well, I just did that. It was 1 over root 3. So the only thing different here is that I have a 2 to multiply in front. 1 plus 2 root 3, fix the denominator, root 3 over root 3, is going to make this 2 root 3 over 3. And now the common denominator makes this 3, 3. So we have 3 plus 2 root 3 all over 3. So you get the idea that these are not tricky. They are just a little complicated looking answers, but it's exactly what you were using before, just combining. They do another example 4 on page 174, root 6 sine of 30 degrees plus 1 over root 2 with tangent of 60 degrees. So my sine of 30, here's my 30. Sine is so, opposite over hypotenuse. Opposite of 30 is 1, hypotenuse is 2. So we're going to have root 6 times, oh, what did I just say? 1/2 plus tangent of 60, here's my 60, TOA, opposite over adjacent, so that's just root 3. We have our 1 over root 2 with our just root 3, yeah, just root 3. Implied over 1 if we want to go ahead and write it. So this is root 6 over 2 plus root 3 over root 2. Need to fix that. Multiply by root 2 over root 2. This one I'll write out. So I'm keeping root 6 over 2 plus root 6 over 2. Ooh, same denominator. How nice. A root 6 plus a root 6 is 2 root 6's over a base of 2. Oh, 2's cancel, and just root 6 for the answer. Part B is a combination of functions. So we can have an f of x plus a g of x, and that would mean take these two equations and add them together. Same thing if I subtract them. Same thing if I divide them. Same thing if I multiply them. The weird one is when I write this, and it looks like fog, but I'm trying to give a little circle symbol in here, and then the x. And they will often put that in a parenthesis so that you know it's not just g of x, this is this together. And what that means is that I take g's equation, whatever it is, and I plug it in to f's equation. So if we look at example 5, they tell us that f of x is log x, g of x is x squared plus 6, and it wants us to find g of f of x. Okay, so it wants me to take f's equation, the second one, and plug it into g's. So this log x is substituting in to g's equation. So that means I'm going to have the log of x squared plus 6. Now I can write it that way. That is how the book wrote it. Or you can write it log squared x plus 6. Either one of those is an okay way to write that. Now that you're getting the idea, example 6 says f of x is x plus 2. G of x is x squared plus 3, and it wants us to do, wait a minute, I think I may have flip-flopped, x plus 2, g of x, x squared plus 3. Nope, okay. There are 4 things they want me to do. In A, they want me to do f plus g of x. So let's do that first. They want to take the two equations and add them together. That will be x, I'm going to put it in order, x squared plus x plus 5. And then in A, it also said to plug in a 6 rather than just the x. So now I'm going to do 6 squared is 36 plus 6 plus 5, 47. Then it wants me to do f minus g and then plug in the 6. So we're gonna put these two equations together, x squared plus 3 minus this whole unit. So it's gonna be minus x minus 2. If you want to write it separate with the parenthesis of minus x plus 2 and then distribute the negative, you can do that. It's all fine. Simplified x squared minus x plus 1, and then we plug in the 6's, so we have 36 minus 6 plus 1, so that should be negative 30 plus 1. I was trying to check their answer to make sure I was on track. Yes, B wanted f minus g. Did I write that backwards? Oh, I did, because it didn't matter on this one, but it does on this one. Scratch that. Let's try that again. You do have to pay attention to the order. So this should be x plus 2 minus x squared plus 3. This one I will distribute to show you how that looked. X plus 2 minus x squared minus 3. Now putting it in correct order. Negative x squared plus x minus 1. Ha ha ha. So plugging in 6 squared 36, that's negative 36 plus 6 minus 1. Negative 30 minus 1 more is negative 31. And that is the subtracted answer. Okay. They also want in C the multiply. That's going to take x plus 2 and multiply it with x squared plus 3. And before I can plug in the 6's, I need to distribute this out. So x times x squared is x cubed. X times 3, 3x. 2 times x squared, 2x squared. And 2 times 3 is 6. These should be flip-flopped to be in descending order, but it's not going to matter. I'm going to plug the 6 in as they asked. Ooh, this is trickier. 6 times 6 is 36. Times 6 is much bigger. I want to say, oh, they didn't show it. 36 times 6, 6 times 6, 216. I believe that's right. 216 plus 3 times 6 is 6 squares 36. 36 doubles to 72 plus 6. Harder to do in my head. Their answer is coming out 312. Trying to check to make sure that's right. 78 if I do those two with 24. 102 with 216. One of those numbers is definitely off then. You've probably already figured out where I boo-booed in my multiplication, and you're doing it on your calculator. 312 is the answer that you're looking for, so I obviously have a number that's dorked somewhere. And the final one in D is f divided by g. So that's going to give us x plus 2 over x squared plus 3. And there's nothing I can do to simplify that, so I just need to plug in the 6 as asked. So 6 plus 2, 36 plus 3, 8 over 39, and it does not reduce, so that's the division answer.